start comparing proposals from different contractors, you're going to see that everyone has a different way of doing it. Now, what we do is we really look at the science behind seismic retrofitting, and in this proposal, you're going to see the science that we have based your retrofit on. In seismic retrofit work, we don't look at Richter scales. In other words, we're not trying to resist a 7.5 or 7.3. We don't design around that. What we design around is a ground acceleration. So we have an anticipated ground acceleration here in the San Francisco Bay Area of 0.186 Gs, and that's what we need to design against, and I'm going to show you how that's done. So what we have here is the ground acceleration is pushing at the base of the house just like this. So what's happening is the ground is moving this way, and inertia is causing this house to lean, and it's going to want to try to slide off the foundation right here. So in a seismic retrofit, we're trying to prevent that from happening. So I want you to notice how this movement right here, underneath the house, is identical, at least what happens here, is identical to a force that is pushing on the house right here. So what we do is we figure out the weight of the house, and we have the ground acceleration underneath the house. And when we multiply those two together, we end up with pounds of force. So we look at, we translate that ground acceleration into pounds of force that are pushing against the house. So all the hardware and plywood and whatever it is that we happen to use in a seismic retrofit is designed to resist a certain number of pounds of force. So we have pounds of force that are pushing against the house, and then we have pounds of resistance provided by the retrofit hardware. Let me show you how all of this would work by using an example. So let's assume the plywood we're putting in can resist 1,000 pounds of earthquake force for each linear foot. And the bolts resist 2,000 pounds of earthquake force. And the shear transfer ties resist 500 pounds of earthquake force. Now realize that these are hypothetical. They're just for educational purposes only. Real shear transfer ties, real bolts, real plywood does not resist this amount of force. So just keep that in mind. Now if we have 10,000 pounds of earthquake force going in this direction, we're going to need 10 linear feet of plywood, which equals 10,000 pounds of resistance. We're going to need 20 shear transfer ties, which equals 10,000 pounds of resistance. We're also going to need 5 bolts, which can equal 10,000 pounds of resistance. So you can see, we just want to make sure that the bolts, the plywood, the shear transfer ties can resist the amount of force that is going to be trying to push the house off the foundation. Now, in the same way, when earthquake forces come in this direction, we also need 5 bolts, 20 shear transfer ties, and 10 feet of plywood in order for our retrofit to work as it should. Now we need to figure out exactly how many bolts, how many shear transfer ties, and how much plywood your house needs. Now we use engineering calculations to do that. The calculations we use are the basis of a regional guideline called Standard Plan A. I was on the committee that developed those standards, and I happen to have a copy of the calculations, and we use these in every single retrofit we do. There was a specialist in seismic retrofitting, and he spent about 2.5 months putting these calculations together, and as you can see, they're pretty exhaustive. And so when we use those calculations, we determine exactly how many bolts you need, how much plywood you need, and how many shear transfer ties you need. These calculations tell us how much earthquake force that house we need to resist, and that's measured as a G-force. So what they do is they take the G-force and you multiply it by the weight of the building, which is also determined by these calculations. It looks at the weights of houses with stucco on the outside, sheetrock on the inside, shingles on the roof, plywood floors, old wood floors, every kind of configuration you can imagine, which is what took all the time for Jim Russell to do this. But anyway, we figured out the weight, we multiply it by the ground acceleration, and then that gives us a certain number measured in pounds.
Now it's critical to remember that every piece of plywood, depending on how it's nailed and put together, can resist a certain number of pounds of force. And we always put in the very strongest plywood we possibly can. And also same with bolts. Bolts are, very different types of bolts. There's some that are used, in certain special applications that regular bolts, won't work in. There's half-inch bolts, there's 3/4-inch bolts, there's 5/8 bolts, there's different types of washers. It goes on and on. Those can also resist a certain number of pounds of force. And the same thing with the shear transfer ties. So they're all there that resist certain force. Now, the idea of a retrofit is to make sure that enough of those components can resist the amount of force that is anticipated. So we'll take your house. We assume there's going to be a ground acceleration of 0.186 Gs. That's going to give us a number measured in pounds. And then we just make sure there's enough plywood, there's enough shear transfer ties, there's enough bolting hardware to resist that force, and then your house is retrofitted. So let's go ahead and take a look at your house specifically and see what that looks like.